Today we're going to begin Chapter 5, looking at Lesson 5.1, Trigonometric Identities. Now, the first two lessons in Chapter 5 are preparing us to, in Lessons 5.3, 5.4, 5.5, solve and evaluate trigonometric equations and expressions. But we need to be able to work with different trigonometric expressions and be able to simplify those using our identities. Okay, the focus on today's lesson, the first part of Chapter 5, examples 1 and 2, are the reciprocal identities, the quotient identities, and the Pythagorean identities. Now, we're going to begin class later this week in person, and we're going to derive and prove these three different types of functions, but today I'm just going to introduce them to you, and we're going to practice working with them. Before we begin, I would like for you to pause the video, read pages 312 and 313 out of your textbook, and complete the vocabulary for identity, trigonometric identity, and cofunction. Okay, once you read those two pages, I believe you'll have to go to the next page, 314, to get the definition of a cofunction. But I want you to read through those two pages and the examples and write down the definitions of these three vocab terms, then hit play, and we'll begin with example 1. So I'm assuming you've read pages 312 to 313 and found definitions for each of those three words. Now we are going to begin by looking at example 1, focusing on the reciprocal and quotient identities. In letter A, if secant x equals 5/3, find cosine x. Now we know from early in chapter 4 that cosine and secant are reciprocal identities. So we're going to go to the left, and if I'm finding cosine, go to my reciprocal identities, I know cosine theta is equal to 1 divided by secant theta. Okay, so what I know is cosine of x is equal to 1 divided by secant x. If I plug in what I know, then cosine of x is equal to 1 divided by 5/3. When we divide using fractions, we can simplify by multiplying by the reciprocal, so this is equal to 1 times the fraction 3/5. So cosine of x is equal to 3/5, which notice is the reciprocal of secant at 5/3. Okay, letter B, I made a little change to our problem. So I'm going to cross out cotangent of beta equals 25/27, and I would like for you to replace that with cosecant beta equals 25/7. So if cosecant beta equals 25/7 and secant beta equals 25/24, we want to find tangent beta. Now again, we're going to be using our reciprocal and quotient identities. We are no longer going to draw triangles. Okay, we're going to move to using our identities, which is a more efficient method in solving these problems. Okay. All right, if I need to find tangent beta and I look at my quotient identities, I know tangent is equal to sine divided by cosine. Okay. So off to the side, I'm going to remind myself that tangent of beta is equal to the sine of beta divided by the cosine of beta. Okay, and beta is just our variable that represents our angle. Now, I need to find sine, and I know sine is a reciprocal of cosecant. So I know that sine beta is equal to 1 divided by cosecant beta. They're reciprocals. Okay, so plug in what I know. Sine beta is equal to 1 divided by cosecant beta is 25/7. Okay, that same thing as multiplying by the reciprocal, so it's 1 times 7/25, which is equal to 7/25. Okay. So I know that sine of beta is 7/25. Okay. Now, secant beta has a reciprocal of cosine. Okay, so remember, I know that cosine of beta is 1 divided by secant of beta. Okay. Now my cosine of beta is equal to 1 divided by secant beta was 25/24. So when I multiply by the reciprocal, then cosine of beta is 24/25. So I'm going to replace cosine beta with 24/25. Okay. So tangent beta is equal to 7/25 divided by 24/25. Dividing by two fractions is the same as multiplying by the reciprocal. So I can take 7/25 times the reciprocal, 25/24. Okay. I can simplify by reducing, and that means tangent beta is 7/24. This is an example of using both reciprocal and quotient identities to solve a problem. Okay, example 2, we're going to focus on the Pythagorean identities. It says find the value of each expression using the given information. Again, we are not going to be drawing triangles. So if you're given a test or quiz and even homework and you start drawing triangles, I'm going to give it back to you and ask you to redo it. Because for these problems, we're going to use our identities. Now, the Pythagorean identities, there are 3 of them. Again, we're going to derive these next time in class. I'm just going to introduce them to you today. The most common is the first one, sine squared theta plus cosine squared theta is equal to 1. We have tangent squared theta plus 1 equals secant squared theta. And we have cotangent squared theta plus 1 is equal to cosecant squared theta. Those are the Pythagorean identities, and we're going to use those in addition to reciprocal and quotient identities to solve the following problems. Okay, letter C. We have cotangent theta and secant theta is what we're trying to find. We're given that sine theta is equal to 1/3 and tangent theta is less than 0. Okay. Now, a couple of things that I need to note. Tangent is negative. That can occur in quadrants 2 and 4. Sine theta is positive. Sine is positive in quadrants 1 and 2. Okay. They both have quadrant 2 in common. That means, okay, if I were to draw a triangle, it would fall in quadrant 2. This is going to help us determine which values are going to be positive or negative. Okay. Now, if tangent is negative in quadrant 2, then cotangent is also going to be negative. So keep in mind my value for cotangent will be a negative number. Okay, secant is the reciprocal of cosine, and cosine is negative in quadrant 2. So keep in mind my answers for both cotangent and secant will be negative because this angle is going to fall in quadrant 2. Okay. Now I'm given sine theta is equal to 1/3. If I'm given sine theta, okay, I could use the first Pythagorean identity, sine squared theta plus cosine squared theta is equal to 1. Okay, so I'm going to write that down. Sine squared theta plus cosine squared theta is equal to 1. I know sine theta is equal to 1/3, so I'm going to plug that in. Now, this is sine squared theta, so when I plug it in, sine theta is 1/3, and I'm going to square that because this quantity is being squared. Then I have plus cosine squared theta is equal to 1. And I'm going to solve this equation for cosine. If I square 1/3, 1/3 times 1/3 is 1/9. So I have 1/9 plus cosine squared theta is equal to 1. Now, since I have a fraction with denominator 9, I'm going to rewrite 1 to be the fraction 9/9. Okay. I'm going to subtract 1/9 from both sides. So So I have cosine squared theta is equal to 8/9. And to go from cosine squared theta to just cosine theta, I take the square root, just like we do when we have an x value squared. Okay. When I take the square root of cosine squared theta, I just get cosine theta. Okay. Now, when you take the square root of a fraction, you take the square root of the numerator and you take the square root of the denominator. Now, the denominator is the easiest. The square root of 9 is 3. Okay. Now, when I take the square root of 8, I have to simplify the radical. And I know that the perfect square that divides into 8 is 4, so this is equal to the square root of 4 times the square root of 2. Square root of 4 is 2, so this is 2 radical 2. Now, cosine, we said had to be negative because this falls in quadrant 2. So remember, when you take the square root, you get plus or minus. And we have to determine if we're going to use the positive value or the negative value. And in this case, we would use the negative value because this lies in quadrant 2. So cosine theta is negative 2 radical 2 divided by 3. Now, I was asked to find secant theta, and I know that secant is the reciprocal of cosine. So secant theta would be equal to the reciprocal of that, negative 3 divided by 2 radical 2. We cannot have square roots in the denominator, so we have to rationalize. So I'm going to multiply the numerator and the denominator by radical 2. So 3 times radical 2 is negative 3 radical 2. 2 radical 2 times radical 2. Okay, radical 2 times radical 2 is 4. So this is equal to 2 radical 4, or 2 times 2, which is 4. So secant theta is negative 3 radical 2 divided by 4. Now that took care of secant theta. So I used the Pythagorean identity to find cosine, and then the reciprocal identity to get secant. Now I want to find cotangent theta. Okay? I have two choices for cotangent squared theta. I could use a quotient identity, where cotangent theta is equal to cosine theta divided by sine theta. That's one option. The other option would be to use the Pythagorean identity, cotangent squared theta plus 1 equals cosecant squared theta. And since I know sine is 1/3, I would take the reciprocal of 1/3, which is 3, and that would be cosecant. Okay. I'm going to choose the quotient identity. So I'm going to choose the fact that cotangent theta is equal to cosine theta divided by sine theta. Now, we found cosine theta to be negative 2 radical 2 divided by 3. And we found sine theta, it was given at 1/3. Dividing fractions is the same as multiplying by the reciprocal. So I have negative 2 radical 2 divided by 3 times the reciprocal of 1/3 is 3/1. When I multiply straight across, simplify in advance, 3 divided by 3 is 1, and cross those out. So cotangent theta would be equal to negative 2 radical 2. And again, it is negative, as both cotangent and tangent are negative in quadrant 2. Okay, let's try one more. Okay, letter D. I want to find sine theta and cosine theta. I am given that cotangent theta is equal to 8 and cosecant theta is less than 0. Okay. Now, cotangent is positive. Cotangent is the reciprocal of tangent, which is positive in quadrants 1 and 3. Now, cosecant, which is the reciprocal of sine, is negative. So between quadrants 1 and 3, sine and cosecant are negative in quadrant 3. So this triangle, if I were to draw one, is located in quadrant 3. But we're not allowed to draw triangles. We have to use our identities. Now, I am given cotangent theta. So when I'm looking at my Pythagorean identities, I'm going to use cotangent squared theta plus 1 is equal to cosecant squared theta. Okay. So I'm going to copy down the Pythagorean identity in letter D. I'm going to plug in what I know. Cotangent squared theta. Okay, cotangent is 8. I have to square that. So I have 8 squared plus 1 is equal to cosecant squared theta. 8 squared is 64. 64 plus 1 is 65. Okay. Now I got to take the square root to go from cosecant squared to just cosecant. Okay, when I take the square root, I get plus or minus, but I was given that cosecant is negative, so I have to use negative radical 65 is equal to cosecant theta. Now, I was asked to find sine theta, and sine theta and cosecant theta are reciprocals. Okay, so I know that sine theta is equal to 1 divided by cosecant theta. So sine theta is equal to 1 divided by negative radical 65. We have to rationalize because we cannot have a square root in our denominator. So I'm going to multiply numerator and denominator by the square root of 65. And sine theta is equal to negative radical 65 divided by 65. Okay. Next, I need to find cosine theta. Again, I can use a Pythagorean identity or a quotient identity. I like using the quotient identities the second time around. And I know that cotangent theta is equal to cosine theta divided by sine theta. Cotangent theta is equal to 8. That was given. I want to find cosine theta, so I'm going to keep my numerator. And then sine theta is negative radical 65 divided by 65. I need to solve for cosine theta. Now notice I am dividing by negative radical 65 over 65 on the right side. The opposite of dividing is to multiply. So I'm going to multiply both the right side and the left side by negative radical 65 over 65. Notice this is different than a reciprocal identity. This is not reciprocal, so I'm not going to multiply by the reciprocal. I am undoing, taking the inverse of the operation. That cancels. Then on the left side, 8 times negative radical 65 is negative 8 radical 65. Divided by 65 is equal to cosine theta. In quadrant 3, both sine and cosine are negative, so I just double check that my signs are also accurate. Okay. I would like for you to turn the page and attempt letter E on your own. Okay. After you get an answer for letter E, I'm going to have you upload the first 2 pages of your notes. Make sure you have your vocab complete, example 1 complete, example 2 complete, and you try letter E. We will cover example 3 in class. Good luck.